Hello. Today I will discuss how to do SQL retrieval with LlamaIndex, or in other words, how we can set it up for LLMs to interact with SQL databases to generate accurate answers. So with this goal in mind, I want to cover a few things. First, how we can create a SQL database with Python, how we can create a LlamaIndex query engine that interacts with SQL. Then there's also an enhancement to make the SQL query retrieval even better with entity resolution. And then finally, I'll quickly cover how to create a custom LlamaIndex query engine. So the first question you should always ask is why? So why are we using SQL retrieval? Why can't we just send our questions directly to an LLM? Well, the reason is because an LLM's knowledge base may not be sufficient to accurately answer our question. And there are two reasons for this. First is the knowledge base cutoff date, and also that the question is about a niche topic that is not highly present in the knowledge base. So if we have a SQL table that contains the specialized information, then the LLM can retrieve that information and accurately answer the question. For example, if you are running a social media application, then you may have a table with user activity, and the LLM can retrieve content from the table and answer user questions. Or if you have an e-commerce store, then you may have a table with sales and transactions, and you could have the LLM interact with those tables to properly answer any questions. So for this presentation, I'm going to work with a simple soccer player data example. And suppose we're building an application and we want to answer questions about soccer player stats. So we may expect our users to ask questions like how many goals did the player score, or how many assists did the player have in a given season. So I've already stored a lot of player stats on my local machine as text files. And here I'm just going to read one of the stats. I'm going to read it as a Pandas data frame right here. And this is the output that we get. And here's a schema of each column that the data provider gives us. So we can see things like goals, assists, penalty kicks, cards, goals per 90 minutes, and so on. So we want to leverage all these statistics when answering the user questions. Okay, so now that we have our data, let's start to load the data into SQLite. I'm using SQLite because it's a very quick and easy database to get set up locally. But in general, this pattern that I'm going to share in this presentation should work for any other database. So here I am importing the create engine function from SQL Alchemy, and I'm going to create an engine for a local SQLite database, which is going to be called footballstatsdemo.db. Then I'll take the data frame that I had in the previous slide and load it into a table called player stats. And you can see here that we've loaded 19 records. I'm also going to load another player stats here. So I'm going to read a different stat sheet for a different player, load it into a data frame. And here in the last line, I'm going to call the .toSQL to load it into our SQLite database. And I've created a convenient helper function here called run query, which establishes a connection to the table or to the SQL table, and then lets us run a queries on it. So for example, here I'm showing how many records are there in the player stats table. We have 36 records, and we have loaded two different players here, Declan Rice and Bukayo Saka. So now that we have our data ready in a database, let's set up our LlamaIndex query engine to connect with the SQLite database. So from LlamaIndex, I need to import SQL database and the NL table query engine. First, we're going to wrap the SQL database connection with LlamaIndex's SQL database wrapper. Then I'm going to create a query engine, and there are three parameters here. We have first the SQL database connection. There's a specific table we want to connect to. In this case, it is the player stats table. And then finally, there is a context string where we need to provide context about the table. And here I will show you what I have set up for the table context. And as I said, the table context is basically a description or schema of the table. So here I have a brief description about what the table is about. And then here I break it down by different columns. I provide the column name and the description of the column. And then for each of the columns, I have grouped them by certain categories, like playing time columns, like NP, starts, min, and 90. Then there's the raw performance columns, like goals and assists, and so on. And it's very important that we give this table context because the LLM needs to know what type of data is in the table and what each column means. Okay, so now that we have our query engine set up, let's try to ask some questions. So my first question here is, how many goals did Bukayo Saka score in the 2025-2026 season? And I have a question here, and then I pass it to the query engine. So I do query engine.query, and then pass in the question. And the response that I get here is that he did not score any goals in the 2025 season. And if you're a fan of Arsenal or the Premier League in general, then you would know that this is incorrect. So now let's try to rephrase the question. And instead of giving his full name like that, instead we're going to reformat it to be Bukayo_Saka with all lowercase. Now, if we pass in this new question to the query engine, you can see that it shows that he has scored 6 goals in the 2025 season. And this is accurate as of this recording time, this is accurate. So what's going on here? Because clearly we can see that this approach is not working out of the box. And the reason why it's not working here is because under the hood, the LLM is converting the question into an equivalent SQL query, right? And so that's what we're going to look at here. So if we take that first question, it's going to convert it into this second query here, where it's saying select goals from player stats where player name is Bukayo space Saka and the season also. But the thing is, in our database or in our table, we don't have any records where the player name is in this format. Instead, we have records in our database with player names following this format of Bukayo_Saka, right? And so when we run the second question, it's going to create this query here where player name is equal to Bukayo_Saka. And since we have records in our table, it's going to get 6 goals for him. And this is a problem, right? Because in the real world or in a production use case, users are going to misspell players' names or are going to search with the last name. It's very unlikely for a player or for a user to search with this specific name format. So how can we resolve this? Well, fortunately, there is an easy way to do this with entity resolution. So we can use embeddings to find the closest player name match. And it's not too difficult to do this with LlamaIndex. So for now, let's suppose that our database only contains 2 players. And the names in the database are going to be like these, Bukayo_Saka and Declan_Rice. So with these valid player names, we're going to create a vector store index. So that's what we see in these 2 lines here. Then with that index, we're going to create a retriever to retrieve the most relevant name from the table, from the index. Now with the name retriever, I'm creating this helper function called getCanonicalName, where you pass it a user query, and it's going to find the closest matching player name in the database given the user input. And that's what we see here. I'm calling getCanonicalName. I'm passing in Saka's last name, but misspelled, and it's able to retrieve Bukayo_Saka. So this is how our database stores his name. And this is good because now we can pass this value into our downstream query engine to retrieve relevant data. So let's see how all of this works together. I've created a helper function called askStats where we pass in a user query. So with that user query, we're first going to get the canonical name, or basically the name that matches in our database. Once we have that, we're going to enrich our query to include that canonical name. So that way the LLM knows exactly which player name to use. Then with that enriched query, we're going to pass it to our stats query engine to generate a response. And then I'm just going to return the response along with the canonical name. And that'll just be proof for us to know that we are retrieving from that record in our table. So now if I ask the question again, how many goals did Bukayo Saka score in the 2025 to 2026 season? I'm getting a correct answer that he scored 6 goals in the season. And also it's showing that the source is this player name. Okay, so this is good. And now quickly, I'll cover how to create a custom query engine for the askStats function that I just showed. This is more of an advanced topic because as you get further into LlamaIndex patterns and orchestration techniques, you'll realize that you need everything to be in a custom query engine. So basically, we are creating a class from the custom query engine, and we need to implement the custom query function. And in our case, we're just going to execute the askStats function. So now with this new query engine, I'm going to ask the same question, and I get the correct answer that he scored 6 goals in the 2025 to 2026 season. In conclusion, we have created a real example of LLMs interacting with SQL tables. Based on your application, the data in a SQL table can provide more relevant data to an LLM to generate a more accurate answer. And we also learned how to resolve a common issue of messy user input with entity resolution. There are a couple of important callouts for LLMs with SQL tables. And the first is that we need to be very cautious about an LLM running queries on our production tables. We want to avoid any modifications or deletions to the table and also avoid expensive queries. Now, one way to do this is through more explicit instructions to the LLM, but there's also a concept of human-in-the-loop workflows, which we should further explore. Thank you.